Hello everyone, and thank you for another episode of Maximum Code. In this session, we're going to take a look at how to deal with images, specifically how to manipulate images. We're going to do this in using system.drawing. We'll keep this session for the system.drawing, and then in the next session, we will go ahead and look at it doing exactly the same thing using Ski Sharp. There are differences between system drawing and Ski Sharp. You cannot work with Tiff Images in Ski Sharp as of right now. Let's get started and manipulate some images. So let's go ahead and reference the system.drawing through NuGet package. So we've created a very simple console application to test the installation process. Let's go ahead to browse and search for system.drawing, and let's go ahead and select the latest version and install. So now that we have the package installed, let's go back to our program and create a very simple image. We're going to go ahead and work with the bitmap image. So we're going to go ahead and use the bitmap class. And the bitmap class inherits from the iDisposable, so we have a using statement for that. And we want this image to be 128 pixels in height and in length. So now that we have our image object, we're going to call the save method and pass the file name. And this should actually create a test.png for us. So if we go to where the executable is in the bin directory and debug and netcore 3, we'll see that we have our test.png. If we open it, it opens the Windows default photo viewer. But if we choose to open it in Paint, we can see that it is 128 pixel by 128 pixels. We didn't do anything as far as having text or anything else, so that's why it's just blank. So let's go ahead and learn how to open images and also do rotation, rotating the image in different ways. So here we have a image that we created, hello world. It's a very small image, and this is the image we're going to be working, and we're going to learn how to rotate this as you see on the screen. We're also going to learn how to actually flip this image into like a mirror reflection or whatever. If you open it in Paint, you'll notice that it's 827 by 407 pixels. And so let's actually learn how to open images. There are several ways you can actually use the bitmap class. There's a static method on it, or you can just create it by newing a bitmap object and then passing some values to it. So you can either pass an image object and you'll get a new image. It's like cloning an image, or you can get a stream. So you could do this by file open read and then pass a path to the image, and that returns a stream, which then internally can be used to create an image object. Or you can actually just pass the file name path, and then the image will be constructed for you. So let's go ahead and pass the path that we have for our image. So now that we have the image, we can then do many things with it. And one of the things we said was going to rotate it. So you have a rotate flip method, and then it accepts a enumerator, and this enumerator will tell it in what degree to flip and rotate. So now we're saying to rotate 90 degrees. But we're telling it there's no flip, meaning there's no mirror image off of this, just rotate this. To see this in action, we need to then save the image back as a different file name, so we can see the before and after. Let's just actually also name this something so it's very specific to what we just did. And then let's go ahead and run this code and then see what the result is going to be. So if we go back to the folder, you'll notice we have a new image and it's now rotated 90 degrees. If you wanted to rotate it again, you could do so, either just keep rotating it 90 degrees, or we can just say rotate 180 degrees, and then again, no flipping. We'll just keep it as is. And let's do this. Okay, let's go ahead and run this. And if we go back to look at our folder, and you'll notice that now we have the image, which is 180 degrees. It's upside down. And then if you were to go ahead and do the rotation with the flip, so we're going to choose the X coordinate flip. So this will be, it's just going to mirror the image. There's no rotation on it, just to see what it looks like. So now if we go to the folder, you'll notice that the image is now a mirror reflection of what the original image was. It's because we did the X coordinate. If we did the Y coordinate, it would be from top to bottom flip. So now if we do a rotate 180 degree with a flip, let's take a look and see what that would look like. And again, it's upside down, but the mirror image of it. So this is great that we can flip it in so many degrees, but what if you wanted to control the degree in which you wanted to rotate the image? To do that, we'll have to write some code to work with the rotation, and you do that by doing some math to figure out and calculate the new image size, and then do the manipulation. So we're gonna go ahead and copy and paste some code here, and the first thing we're gonna do is get a degree of angle that we want to work with, and then once we get that, then we're gonna run some math to figure out what the new width and height of the image will be, and then use those to go ahead and create a new image and then do the rotation for that. And then the last point is we do an offset. This is where the rotation should happen, when we are actually taking the width and the height, dividing by 2. We're taking the width and the height and dividing it by 2 because we want it to be at the center of the image. So the rotation should be at the center of the image. So let's go ahead and create a new bitmap, and we'll call this rotated bitmap. And we'll create a new bitmap, but this time we're going to pass it some variables, which is going to be the width and the height. So we're going to give it the new width and the new height. It's going to create us a new image with the new height and width that we have specified. And then we're going to actually set the resolution the same resolution as the original image, because we don't want to have any the image should not lose its resolution. It shouldn't degrade, or we shouldn't enhance it either. So we'll just take the original resolution, horizontal and vertical, and the next thing we need to do is, in order to actually manipulate the image, we have to get a graphics object, and we can get a graphic object from the image. So we're going to say graphics from image and then pass it the image that we were working with. So this is going to be the rotate bitmap and not the original image, because this is the image we're going to be generating from the image that we opened up originally. So now that we've got a new graphics and we're ready to do the manipulation, we're going to do a transformation on this. So the method is called translate transform, and basically when we call this method, the parameters that we're going to pass it is going to be the new width divided by 2, and we're also going to do the height divided by 2, because everything we're doing here is going to be from the center of the image. So now that we set up the center, the next thing we need to do is actually do the rotation. So now we're going to call a method called rotate transform, and then pass it the angle in which the rotation should happen, which is 60 degrees. This is what we specified. Let's go ahead and actually create a variable called angle, and then this will be set it only once. And then let's go ahead and paste that there and paste it also here. So now that we have our rotation, the next thing we need to do is draw the image. So we'll still use the graphics object. We're going to say draw image, and we're now going to pass the image we want this transformation to happen, which is the original image. And then it's going to need a point of reference. So we want to make sure that this image is also being rotated from its center. So we're going to create a new point. So our new point is going to be based on our offset value of X and Y. So if you go back, we didn't do anything, and the reason this rotation didn't work is because we actually working with the wrong object. We shouldn't be resaving the current image. We actually should be resaving the rotate image. And now let's go ahead and execute our program. And if you go look at the image, you'll notice that it is actually being rotated, but the image scaled up. And that's why we use the math that we did, is to make sure that the image doesn't get cropped. If you didn't do the math that we have here, then the image would get rotated and it would not get cropped. So here we're showing you now that if you change a degree, it shows you the different degree, which was half of 60, 38 degrees, and that was rotation for that. So here we have our image in Photoshop, and let's go over a little bit more about what we did and how images and cropping would work. So there are X and Y coordinates, but first what you do is in Photoshop you can go here and make sure that the ruler unit is set in pixels so we can see our X and Y values in pixel. So we start with the X from very top, same as Y, 0, 0 is the very position at the end, and then X would be going from left position to the right position, and Y would be going from top position to going to the bottom. So if you wanted to have a point in the image, you would say X 5 pixels and Y 10 pixels. So you would go 5 pixels to the right and 10 pixels down. So wherever X and Y intersect, you would get a point. So here we're saying 50, and then Y is, X is 40 and Y is 50. So we go down, we go to the right 40 pixels, or pretty approximate, and then we go down 50 pixels. Or a pretty close approximation, and wherever that point is, that is where the starting point would be, of where you would want to start a rectangle, or give it a width and a length, and that would actually be your rectangle till you could do cropping. Now in our previous image, what we did was to rotate this image. So basically this is how we rotate it in degrees, except that in Photoshop, as you can see, if you go over, it actually gets cropped. We did some calculation that would expand the canvas so that the image would not be cropped. So you have some ways about how you would want to rotate an image and how you would want it to either preserve the cropping versus no cropping. So if we were to create a rectangle around, let's say, hello, and then let's calculate where this rectangle is starting, its X and Y positions. So it's roughly around 73 pixels X and 146 on Y. So let's also actually fill this in with a color so we can see it a little bit better. Zoom in a little bit. So our X and Y start somewhere between 70 and 140, plus or minus 141 or something, and then the width would be around starting from X and Y to where the end of the rectangle is, and also from the X and Y position going down to for the Y position. So now let's go to our program and actually do the cropping. So we are actually going to load the image a little bit differently. Instead of newing a bitmap, we're actually going to do bitmap.load from file. So let's go ahead and create a variable called image, same as before, and then use the bitmap class and then load from file. So when we pass it a file name, we are actually getting an error, and this is due to the loading the method from file is actually from our base method, which is an image class, and so it's asking us to do an explicit cast, or maybe use the image and then cast it. So you have a couple of options, and here what we're going to do is actually use the image. So let's just put our cast in here because it's returning an image and we don't want that. And you can actually not use the bitmap. You can actually also go and change this to the base class, which would be image. Either way works. So let's go ahead and write some code to crop this. There are a couple of ways you could do this. The easiest way is to actually first define the rectangle where the crop area is gonna be. So let's go to our paint program and see where the crop would be. So let's actually create a rectangle. Let's just zoom in a little bit. and actually draw a rectangle. Make sure we have a nice color. So start somewhere between 81 and 150, our X and Y coordinates. And we go about 269 pixels for the width and 131 pixels for the height. So let's just actually write this out so we don't forget the numbers. So 81 was our X and 150 is our Y coordinate. And then we have our width and height. And that was 269 and 131. And let's type this out as well. .269 is our width, that's the longest section, and then 131 is our height. And so the way to do this is to create a rectangle object using these increments. So now if we go look at the rectangle, you'll notice we have our X, Y, width, and height. And now we can use this rectangle object to pass to our image to ask it to crop this image. Now the easiest way to do this is to actually use the image object and clone this. So basically when you're using the clone method, you're creating a new copy of that image. We don't want to manipulate the existing image, we want to create a new image, and you notice it's expecting a rectangle to be passed in, and we're going to pass it the size that we have for our crop. And the next one is to pass the pixel format, and this is the default is not working here because we need to have the image pixel format. So if we change this back to image and pixel format, that should work. And this will actually return as a bitmap. So we can use this bitmap to save. This is our new bitmap that's been cropped. And let's just name it something useful so that we know, so we can see what the cropping is going to look like. Let's go ahead and execute our program. And let's also go ahead and put using statements just to show you that these are bitmaps and they should be the resources should be disposed. So now that we have our program executed, you'll see that we have our hello world and it is cropped based on the rectangle information that we provided. Let's take a look at how we can resize images. So we'll just grab our line of code for opening our image. And then we will create a new image. And for the dimension of our image, we're gonna actually expand it. So we'll take the width and divide that or times 2 and do the same thing with the height. So we're expanding this twice the size of the original image. So now we have a blank image, twice the size. The next thing we need to do is get the graphics and draw the image to this new size. So in this one, we're getting the graphics from our new image, because that's where we want to draw the new image to. Next thing what we want to do is set the interpolation mode. This is basically telling the image as you expand to fill in the other pixels, because the image is smaller. When you're expanding it, you're adding more pixels. So we're just telling it to fill those pixels so that it'll look like a high quality image. There are other options you can choose. We'll go ahead and let you read up on those to see which one you would want to choose when you're expanding images, or if you're shrinking the image, basically resizing an image. So now that we have set up the graphics for high quality, let's go ahead and just draw the image, and we're going to pass it our image. So we're going to take the original image and try to fit it into the new image that we created. So let's grab the width and height. And then let's go ahead and save the new bitmap. Okay, let's go ahead and execute our program. And let's take a look. So the image is blank, so we probably did something wrong with resizing. Let's go back to our program to see what we missed. Okay, so when we drew the image, we didn't tell it where to begin the image from. So we want to make sure that the XY coordinates starting from the very corner of the image. So it should be 0, 0, and then the length and the width and the height, I should say. So if we execute it now, we should see the image, and we can see our image. Let's go ahead and open this to see if the size is correct. And as you can see, the size is expanded. We can see at 100%, it's at 1654 at 814. And if we look at this one, it's also 100% at 827 to 407. So the image did resize. So now if you wanted to actually shrink the image, so let's just go ahead and divide that by 2. So now we're shrinking it half the size it's supposed to be. And just let's name this something else so that we can see what it looks like. And if we go in here and open our image, as you can see that it is 100% at 413 to 203, so it has been resized to a smaller image. So let's go ahead and open our image, and this time what we want to do is write text to our image. To write text to an image, we need 2 pieces of information. We need to know what kind of font we should use, and we need to know what kind of a brush to use to draw the font onto the image. So now that we have our graphics from our image, we're going to just actually work with the current image. And create a font. We'll just use the Arial with 50 points. And we'll use the graphics this time. Instead of drawing, we're going to do draw string method. And then we're going to pass it the string we wanted to write onto the image, and then pass the font we just created. And then we need a brush. So there are some brushes that we can use. So let's go ahead and use the red brush, and then the point where we want to start actually to write the text. So we can give it an XY, or we can give it a point. So if we go to our image, let's draw this somewhere around where the hello world is. So if we bring our cursor, it could be something somewhere around along 90 to 202 or something like that, or just somewhere pretty close should be fine. Okay, so now that we have the starting point, our brush, and our font, let's go ahead and save the image, but this time to a different name. And let's go ahead and execute our program. Let's take a look. And we do have a hello world image that has the word copy written somewhere pretty close to the hello world. Okay, so here when we actually wrote the copy, it is stamping on top of the hello world. What if you wanted to copyright information and you wanted to, or have a draft so that you could actually see the image but have the text to be more transparent? To do that, we would have to actually use a solid brush, and so let's go ahead and actually see how we can use a solid brush instead of the brushes that we did use. Once we create a solid brush, we can pass it some values of the color. We can create a color from an RGB, which gives us the red, green, and blue colors with an alpha channel. So here we're going to choose the alpha to be 255. It can be 0 to 255. 255 means it's going to be very solid, so if any number below 255 it'll be more translucent. So, and then we're going to choose the red to be 255, and we're going to say 0 for green and blue because we want this to be just as red as the one that we just used. So we're just basically mimicking the brush that we created. So if we replace this and let's just create a new one, so just remember that line. So this should actually create the same image as before. And if we execute our program, as you can see that we have the same copy letter that we had before. And now if we want it to be more transparent, we will take the alpha numbers to be less than 255. So let's say if we create a 125 somewhere halfway in the middle, it should be fine. And if we run the program now, let's go take a look at our image. It is transparent, and if we go a little closer, you can see the text underneath it. So by manipulating the values, we can actually see how we can create a brush that's translucent. So in this example, we're going to transform the image into grayscale. and the code is already written. We found this on the internet. There are many ways of doing this. One of the ways to do this is to actually read the image and then go pixel by pixel, read the color of that pixel, and then transform that color into a grayscale and then write it back. In this example, we're doing it a little bit differently. We're actually creating a column matrix and then an attribute object and then passing the matrix into the attribute, and then we'll be drawing the image. So if we go through this line by line, we open the image same as before, then create a new image with the same width and height of our original image. Then we get a graphic from the new bitmap where we're going to make that into grayscale. Next, we actually create the color matrix. This matrix that you see here is actually the representation of a grayscale. And then we create a image attribute object and then set the matrix to our attribute calling the set color matrix. Next, we need a rectangle to be the exact same size as of our image. And then we tell our graphics to draw the image, and we want that image to be drawn exactly to this rectangle, which is the same size. We're not changing anything. And then we're actually giving the same information again, starting from pixel 0, 0 with the same image width and height. And then we're telling it that it's going to be pixel units in pixels, and then passing our attribute, which has the information about the grayscale. And then we save our image as a grayscale with a hello world. And let's take a look at by running this program and see what is shown for us. So if we run this, we should now see a grayscale image. So if we go back to our program, this is our grayscale. Now before we see that, let's take a look at the original image. Now if you look at the original image, you would not consider that, oh, this does not have any color, but actually it does. And the reason that it does is that if you look, you have some oranges, blues, browns, and the reason for this is that as you zoom out, it makes these little edges much more finer, and that's why they have those colors in there. So you don't notice it when it's at 100%, but if you come closer, you can see that it is a different color. So now if we open our grayscale image, we should not see those colors. We actually should see grayscale. So if we zoom in, and as you can see, there's no more any coloring. It is grayscale, and the image looks almost the same when it's 100%. So now let's take a look at how we can create a thumbnail. So there's a couple of ways you could do this. There's a method within the system.drawing, or you could actually resize the image to the pixels you want. So let's actually use a method to create a thumbnail. So we'll just grab our Hello World PNG file, load it up into a bitmap, and then we'll create another image class which is going to hold our thumbnail, and then from the bitmap we will call the get thumbnail image, and then we will pass it the dimensions that we want the thumbnail to be sized. Now of course, if by putting 100 pixels by 100 pixels is going to skew what the image will be. So you can decide on how you want to choose on the size. Next, we're going to pass it a delegate. Hopefully you're familiar with that. And we're going to also pass it a empty pointer. And so let's go ahead and create a method. Now this method, this delegate, is not really used. So we'll just go ahead and return true just to satisfy the method signature. And then just also with a pointer, it's just going to be an empty pointer. And then when the thumbnail is created, we're going to go ahead and save that and then we'll take a look and see what the thumbnail is going to look like. So let's go ahead and rename this to something more useful. And let's go ahead and execute our program. And let's take a look at the results. So this is the image we chose to create a thumbnail from. And let's now take a look at the thumbnail itself. And as you can see, it's already skewed by the size, you can tell. And it is 100 by 100 pixel, and it's pretty small thumbnail image. So let's go ahead and figure out how to convert images. This is pretty simple actually. What we can do is read the image and then save it as a different format. We don't have to do encoding, decoding for this, although you could go down this difficult route, but this is much more easier. And so let's go ahead and take this PNG and save it into a different format. Let's go ahead and change the extension to JPEG and then choose the format. And that's pretty much all you have to do in order for this to get converted. So if we take a look, and you'll see we have two images. They're exactly the same as far as the value, the data in it, but the size is on the JPEG is a little bit more. This is probably due to the compression that the PNG versus JPEG is using. And if we go ahead and take a look at the properties, you'll see we have some information here about the pixels, about the width and the height, and the bit rate that it's using. And the item type usually is the extension of the file. It is not an indicator that this is a JPEG. If you're interested in understanding how images work, if you research the structure of JPEGs, PNGs, there is a structure, and there are code within the system.drawing that you can actually use to extract that properties. And if you look, we can convert this to all kinds of different types that are supported within the system.drawing, from JPEG to icon to Gifs, even to a TIFF file, meta files, and Windows format files. Okay, now let's figure out how to create TIFF files. To create a TIFF file, you could just take one image, and as you saw as before, you could save it as a TIFF file, but it would be a TIFF file with only one image. The whole idea of TIFF file is that you can actually take multiple images and insert it into the TIFF file. So when you open it with a TIFF editor, you can then see and navigate between the images within the TIFF file. So let's go ahead and choose 3 images from what we've used so far, and basically rename them so that they are unique. And then we will actually take these files and stuff them into a TIFF file. So let's go ahead and just take the names for these files. Now make sure that when you're working with files, we're not actually releasing or disposing any of the objects, so make sure that you're using your statements so that it does get disposed and clean up objects. So now what we're going to do is create a image codec information. This class actually will let us retrieve all of the codecs within system.drawing and then get all of the codecs and then iterate through them. Then we can find the specific one for the Tiff images. So calling a codec, you use the same class image codec info and then call the method get image encoders. You don't have to pass any parameters or anything, and just iterate through this because it's an array. Let's go ahead and also make sure our item is not an object, and let's just do a console.writeLine on the item and some of the properties. Let's just choose the MIME type, so that tells us exactly what type of image encoding we're working with. So let's go ahead and put a breakpoint and execute our program. So now that our program is executed, let's take a look and see what is the output. So if you can see, we have BMP, JPEG, GIF, TIFFs, and PNG codec information, and the one that we are interested is in the TIFF one. So let's go ahead and iterate through this until we find our TIFF. Using for each, but if you're more comfortable, you could actually use link on this so that you can extract the information without having to iterate through it. And as you can see, there's additional information here for extension, file extension types. So if you wanted to use the encoding and figure out what type of extension files there are supported, all this information is here for you. You would just have to use a string split to put those into arrays, and you can iterate through them and get whatever information you want from them. And our TIFF file can have either single if or double if for a TIFF extension. But I think we'll go ahead and use the single if, so it'll just be TIF, three letters. So for the very first file, once we read it, we want to then make sure we go through, find the correct TIFF encoder. We'll just do the iteration, and then we'll just do an if where the MIME type is equal to a TIFF. So once we found the encoder, we will break out of our loop and also set our image and codec info into the image codec info that we have found. Next, we want to make sure that we don't proceed any further if the codec is not found. So we'll go ahead and say that if this is null, just go ahead and return, and maybe put a useful message to the console. So now that we have, let's actually move our image a little bit further down. So we only use the image when we have the codec. And what we need to do now is take our image, save it, but let's take a look at some additional properties, because you can't just save it as a .tiff extension. Although if you did that, you would only have one. So we need to set this up so that when we save this file, it is saved in a way so that it lets us know, let the program know that you are going to have additional images to be stuffed into the TIFF. So we'll give it a name. You can also, if you really wanted to do something with extension file, you could use string interpolation and use the image codec info, go to the file extensions. Like we said before, you could split that and pick a specific array out of the split of the array. So we go ahead and debug this and look at our codec that we've selected. Notice that we have a TIFF, but it needs to be separated by a semicolon. Of course, you also have to clean up the star out of it. Now, this is a very long way of doing it, but we just wanted to show you that if you wanted to make this very dynamic, you can. In this case, we already know that it's going to be a TIFF file, so let's just go ahead and use the TIF extension. And now let's take a look at the additional properties that we need to pass it. So the one that we're interested in is this overload, where we have an encoder. So this is going to be our image info codec. And then we're also going to need to have some parameters. The parameters will tell it, for example, this is the first file within the TIFF that needs to be inserted. There's some flags we need to pass it. So let's go ahead and create an empty variable here. And now let's go ahead and create the encoder parameters. So the class we want to use is the encoder parameters exactly as is. We'll just go ahead and new that. And we want to pass the value of 1 because we want to make sure that the encoder knows that there's only one parameter that we are working with. And so we're going to now set the property param. And the param is an array, so we're just going to set the very first array, which is going to be, so arrays are 0 based, so we're going to set the array of 0 to a new encoder parameter. And we want to make sure that we pass our encoder. Now the encoder is going to be the encoder class dot save flag, because we're indicating that we're saving information into the TIFF. And then the encoder value is going to be a long, so we'll have to do a convert of an enum. And the enum we want is encoder value. And we'll go ahead and use multi-frame. So we are telling the parameter that it is a multi-frame, meaning that it has multiple images. And now let's go ahead and copy paste pretty much everything that we had over there, because we're going to reuse some of these classes. So now let's work on the second image, and we'll just do image save add this time. And this time we don't need to use the name because we already have that in the image, and we're now going to give it the image 2, but we're also going to just pass it the encoder parameters. So let's go ahead and create a new, actually let's reuse the same encoder parameter object and just reset the param array to a different encoding parameter. So because this is the second images, the subsequent images, for the encoder flag, we'll go ahead and say save flag. So we now have to tell it that this is the additional images that are going to be passed into the TIFF. So these are frame dimension page. And let's do the same exact thing for image number 3. So for the save ad, I don't believe we need the image codec info. Let's take a look. Yep, so we can go ahead and just remove the image codec info. So let's go ahead and copy this for the third image. Now we could have just not set the encoder parameter and just pass it exactly as is, and it would have just worked. So we can just delete that line of code. So the last thing we need to do is, because this is the last image, we need to close out the TIFF. To do that, we'll just do image save, but this time with the encoder parameter, no images being passed, and then flushing the encoder so that it actually writes. So let's go ahead and copy our encoder parameter and change the multi-frame to flush. This indicates that this is the end of the TIFF file. So we don't need the image, we just need to do save. So that's pretty much it for this creation of a TIFF. Let's go ahead and run this and see what we get. So the program executed with no errors. Let's go take a look, and we do have a TIFF file. So if we open this with the Windows photo viewer, you can see that we have 3 pages within this TIFF file. If you navigate with the other buttons, you're actually navigating images. This upper buttons are going through the frames of the TIFF file, and those are the 3 files that we stuffed into that TIFF. So now let's take a look how to actually read a TIFF file. So we'll go ahead and bring our TIFF file. We'll just read it as a normal image file. But what we need to do now is to read the number of frames that it has. And to do that, we need a dimension. So let's go ahead and create a frame dimension. From our image. We'll just use the very first frame dimension. And then next we will get the frame count, and we do that by using the image, get frame count, passing the dimension. Now, if you wanted to read every image within the TIFF, you could iterate through the frame count through a loop. Let's actually take a look and make sure we have 3 counts in there, and we do. So now to grab all of the images, we will go ahead and we will create a stream object in memory. and then use our image object to save the current frame into the stream, and then we can save the stream into a file. So the image has select active frame. If we pass it a value of I, well, first we have to pass it the frame dimension, which is what we have, and then passing the frame index. This is going to set the current frame into whatever index value we're passing. Next, we will just extract the frame. And we do that by calling image save and then passing our stream. So we've advanced our image frame, and now we're saving that image into a stream. And let's actually save this as a PNG extension. And then we can take this current frame stream and create an image from it, and then call save with a file name to get saved. So let's actually save this with a dynamic extent or dynamic file name so that it indicates the current frame of the TIFF file. And we'll just use the indexer. So if we execute our program and we go take a look, and sure enough we have extracted the TIFF frames into files. So Visual Studio also has a photo or image editor. So if we go through our drive and find the TIFF file or any images within what we were working with, you'll see that we have a image editor, and you can see the frames. As choosing the different frames, we're actually navigating within the TIFF. And you have additional information here. You can actually edit the specific images. You can change the RGB colors. So you have a lot of options. Now let's take a look at how you would actually get this, because by default this is not installed. So let's just go to our Visual Studio installer. There are two extensions that you need to install. So select your version, modify, and then go to individual components and then search for graphics. Search for graphics, and you see graphics debugger and image and 3D model. If you just selected image 3D model and not the graphics debugger, you will be able to open up different files like PNGs, but not TIFFs, and that's because it's a dependency between a image engine. So it would actually error out. It would get an error message. to create a animated GIF is similar to what we did with the TIFF file, because you have to stuff in frames within the GIF, but you will be working with the GIF encoder. And let's go ahead and figure out what our files should be. So let's actually use the files that we used for the TIFF when we extracted it. So we'll just use these guys. Now, the way to easily work with the files into a GIF animation is to make sure that you convert all your images to a GIF format, and then it makes it much easier to create a GIF, animated GIF from them. So let's go ahead and take care of that now. So now that we have our GIF files, now we should load them back in. Okay, so now that we have our GIF file set up, we need the GIF encoder, similar like what we did with the TIFF file. So let's go ahead and create the image codec info. So now we need to do is create a new GIF file, kind of like we did with the TIFF file, but this time we are going to do it using a stream. So let's actually set that up. And we're gonna go ahead and make this one create, meaning that if the file doesn't exist, to create it for us. And let's go ahead and use the same folder. So now we're gonna work with a few properties. We need to have a property tag for a frame delay. And the next one is going to be a property tag frame loop. Unit bytes, let's just set one for 4. And then now what we need is the property item. Now the reason we did the Gifs and loading back the Gifs is because once you have this GIF file, you can retrieve their property item. You cannot, this is a seal class, so you cannot construct a, you can't new this. So this is the reason why we had to up above create GIF files, load them back into an image file so we could use it. And let's call this one frame delay. So let's go to our first GIF file, get property item, and we want to pass the property tag frame delay. And then we do the same thing for property item, and we're going to create a loop property item, and same thing, get our GIF file. So this is going to be pretty much the same thing, except here we're going to create the property loop. So now that we have this information, now we're going to create the encoder param. So encoder params. Now this is going to be for the very first file, so we'll just name it 1 and create a new encoder parameter file. Same as before, we only want 1 inside of this. So actually this should be parameters. There we go. And then we want the param similar to what we did before. And create a new encoder parameter. And we want this to be encoder save flag because we are saving. And then let's create a long encoder value is multi-frame, very similar to what we did with the TIFF file. So now that we have that set up, let's go ahead and create another bitmap and call this animated GIF and set our first image to this. And now we're going to go ahead and use the frame relay and set a length of 3 times, let's say, our unit for bytes. You can modify these values for yourself to see how the animation actually works. So we set the value to something like new byte, or you could just keep these as defaults as well, so it's totally up to you. And then for loop property item, we're gonna set its value to bit converter and get bytes, and we're gonna actually set this to be a infinite loop. So we're gonna set it to 0, and then we're gonna now take the animated GIF property, and we're actually gonna set the property, and this property is gonna be our frame delay, and then we're gonna do the same thing for loop. And then the next thing we're gonna do is actually take the animated GIF and we're gonna save. And now we're going to save this into our stream file. And just as before, pass our GIF encoder and then encoder param1. We passed the first one because this is the very first image that's being associated to this. And then so just like we did with the other files, we're gonna go ahead and now create a encoder for the other subsequent files. So let's call this encoder params n, because there will be n numbers of images maybe. So a new encoder parameters, same as before, we only want 1. And we want to set the params and the 0 index to be a new encoder parameter. So now for oops, we have to put an equal sign here, and let's make this the encoder save flag, and then let's do our long value encoder value, and this time it's gonna be frame dimension time, because this is animated GIF for the subsequent files. So then we take the animated GIF, the save add. We are going to pass it the GIF number 2, and then we're gonna set the encoder parameter of n, and we're gonna do the same thing for number 3. Or excuse me, this should be 1 and this should be 2. And so the last thing we need to do is similar to the Tiff. We need to flush this. So this is going to be the very last one. Well, maybe we should actually name this to encoders plum flush so we know we're closing. And let's do the animated GIF, save, add, and pass our encoder flush. So if we did everything right, this should actually save the GIF animation for us, and we can actually test this really quickly by creating a test variable, and we're gonna use another class, image animator, and use a method called can animate, and then pass our new bitmap. So let's see, we saved our file into this guy. Actually, we can do this outside of all of this because we want to make sure that that is disposed so we can read back the image. Let's go ahead and put a breakpoint here, and if we done everything correctly, we should have animated GIF. So let's actually see if this is true. This is true. So our program just ended. Let's go back here, and we should have a animated GIF here. So if we open this, as you can see, we can actually see the images are being animated for us. So for this example, we've already written the code out. So we'll just go line by line and let you know what exactly we did. So the first thing is we're creating an icon, but we're using a class that has an icon, probably saved as a resource within the DLL, and we're extracting that as a icon one. Next, what we do is we create a stream, and we name it the same thing as the icon we just loaded, with the file extension of ICO, and we have file mode create new so that we create a new file. Next, what we do is we take the stream and put it into the icon, and then we basically dispose this. So there's ways we can actually create a stream and put that into icon as well. So the next thing we do is we actually use the extracted associated icon. So for this one, we're actually going to Windows folder, the explorer.exe. So if we go into create a new file explorer, and we navigate to our Windows and go where our explorer is, so we're basically going to this executable and extracting the icon from it. So now that we have the icon, then what we do is we go to our icon file, because we just saved this as a file because we put the stream in there. And so now we're going to load that file. This is why we also dispose these two objects, so that we can have that access to this file. And then we save those file into bitmaps. So bitmap 2 and bitmap 3. Then we take the bitmap 2 and bitmap 3 and we save it as PNG. Well, this one is bitmap, so we can actually change this back to PNG. And do the same thing here. And if we execute this, we should see three files, one a icon file and two PNGs, one for the Explorer.exe and one for the actual exclamation PNG. So let's go ahead and execute our program. Execute it successfully. So let's go here, and as you can see, we have our PNG for the Explorer. We have our icon file, and we have our PNG. Now let's take a look at how we can actually install the library onto Ubuntu. So same as before, we create a blank project using Visual Code. and then add the NuGet library package. So once the library is installed, there are two other additional libraries we need to install. And this is going to be lib c6-dev. Let's just give our password. And once this is completed, we need to also install a second library, and that's the GDI plus library. Okay, let's go ahead and type library libgdi plus. Oh, looks like we did not, we misspelled it, so let's try that again. Okay, so now that the libraries have installed, what we need to do is just go ahead and create a blank image just to make sure that everything is working. Let's go ahead and run our program. And it ran successfully. And if we go to our Explorer where the project's installed, we have our file. So now let's do the same thing with our Mac. Let's go ahead and add the NuGet package and search for the system drawing common. Add the package. So let's go ahead and just set up our application by adding a blank image. Now this is going to run to an error because we don't have the same libraries that we installed on Ubuntu. So now if we run the program, we're gonna get an error, and the error is being thrown at the safe native methods on the GDIP, which is looking for the GDI plus library, which we don't have. So let's open up our browser. So we need to go and install Homebrew. So now that we have Homebrew installed, let's go ahead and install the libraries that we installed for Ubuntu, which is libc6-dev. Of course, using the brew command. And let's do the same thing for the GDI plus. So now that we installed all the packages, let's go ahead and run our program. And it executed without any errors. So now if we go into our folder, we should see a PNG file, a blank PNG file. And sure enough, we have a blank PNG. And we have a successful installation. So this concludes the part 1 of how to manipulate and work with images, and part 2 we'll take a look at how Skia Sharp can do the same functionality. We do have to point out that some features are not going to be available in Skia Sharp, but when we go over part 2 of the manipulation of images, we will point that out. Thank you again. We'll see you in the next tutorial.